All right. Well, thanks everybody for joining. This is our presentation on Ansible and Terraform. My name's John Webb. I'm in the Garage Solution Engineering team. Co-presenting with me today is Noel Cologne, also in the Garage Solution Engineering team. Um, and welcome. This is kind of a strange event for us to be presenting remotely like this. I know it's kind of strange for us as well as you, so bear with us if there's any background noise or issues with communication. We'll try to make things as smooth as possible. Just a bit of housekeeping up front. We've got the chat for any questions. If you guys are, otherwise um, engaged with other activities and can't speak up or not in a place where you can, pose a question verbally, feel free to chat, type it into the chat. We'll be trying to monitor that. But other than that, if you are, feel free to interrupt us. You can go off mute and ask questions throughout. With that, let's just jump right in. Okay, so the key to this whole presentation is really this concept of infrastructure as code. And so, you know, why is this important, right? And what is this what is the main theme that we're sort of trying to get across in this presentation? The first thing is we want to make sure that we're as we're developing things, that we're doing things in a very repeatable way. And this concept of infrastructure as code is really key to that, right? Moving away from runbooks and folks manually executing commands into this infrastructure as code concept where we're creating this declarative markup where we are telling or defining what that environment should look like. And infrastructure as code is important, right? It's really has some tangible benefits. We look at the cost reduction, um, uh, increased velocity, right? We can execute things much faster, and in doing so, we also remove human error from the equation. So we reduce risk, which also allows us to spend our time in more um, beneficial tasks to our line of business. So um, when we talk about these concepts throughout this presentation, Noel and I are have been doing this for numerous years, and we're really just trying to share some of the best practices that we've developed in our experiences when working with this. We both work a lot with um, defining environments, spinning up environments, testing, tearing them down, and found that automation and these concepts that we're going to talk about in this presentation really are beneficial to us, and we use them in our day-to-day jobs. Um, so the other disclaimer I'm going to just kind of throw out there right at the beginning is, we're not really here to pick a fight. Terraform and Ansible are our tools that we use, that we feel comfortable with. They also kind of align pretty nicely with IBM's portfolio. However, if you happen to like Chef, if you like Puppet, if you've already invested in cloud formations or other tools that do similar tasks in the environments that you need to work with, by all means, continue to use those. We're not saying these are the only tools, but we're more just kind of throwing out our general philosophy of automation is better, and the more you can do this, the better off you'll be as far as management and the tenets there of infrastructure as code. So, one of the things that we see a lot is when we start developing and we start following through, run books or manual processes, we get this, we start seeing this configuration drift, right? So servers will all start out identical. Maybe you use an ISO and you're building a template, and you go through and somebody manually configures one, and then somebody else manually touches another, and then there's a production change and somebody has to create an immediate patch on one, and eventually these little changes add up over time, and you end up creating a bunch of servers that are essentially snowflakes and completely unique. And while doing that, you've basically taken your ability to manage these and turned it all into a bespoke process, right? You can no longer automate to manage. You now have servers that you're afraid to touch, that you can't you can't manage, and so everybody's sort of afraid that you know any change that they make, something's going to break, right? So we call this the automation fear spiral, right? So we get into this this cyclical pattern of um, just inconsistency, right? So the servers are in such a state that everybody is afraid to do anything, right? Even the automation tools that you end up building or implementing, there's a risk that those may break something that's already there, or revert a change that may have already been in place that was a last minute fix. And you get into the spiral, right? So at this point, everything kind of breaks down, and you're managing every single server as if it's a snowflake. And from our perspective, this is really the worst case scenario, because we want to be able to use our automation. If something breaks, quickly fix it, rerun our automation, and have it fixed across the board. We want to, if it's something where we've got a hardware failure and we need to rebuild the environment, we don't want to have to um, go in and fix the hardware. We want to just rip the whole environment down and be able to spin it back up again, really quickly, and turn that downtime, or have as little downtime as possible. So, this is kind of the scenario that we hope to avoid. Okay, so I'll talk about the first part of this chart, and then I'll let Noel kind of introduce configuration management on the bottom. So when we talk about Terraform and Ansible, we kind of split these into two camps. We look at the first half, which is our infrastructure, which is how we align with Terraform. And so when we talk about infrastructure, virtual infrastructure, we talk about VMs, SDN, backend storage, different compute resources, things like that, and these will generally be infrastructure that runs on AWS or in VMware or something like that. And when we talk about automating that, we talk about Terraform creating Terraform templates that define all those components. And there's some parameters that you can pass to it to say, I want maybe a lamp stack, but I want a large lamp stack with this much compute, or a small lamp stack with this. So within the boundaries of your Terraform template, you can pass in parameters to let it know how that Terraform template is supposed to behave. And Noel, you want to talk a little bit about the configuration management with Ansible?
Sure. So while we recommend Terraform for the infrastructure, it'll create your VMs, your load balancers, and your networks and all that. Once we start talking about actual configuration items inside those VMs, something like I want to create a web server, this web server should have this particular configuration, or we want to have this database installed here, we want the web server to talk to that database over there. Those type of items, we refer to those as configuration management. And the tool that we typically like to use for this would be something like Ansible, but you can use Chaff, Puppet, any other. You can either also even use Terraform for this. The point is, we want to maintain a small separation between the infrastructure and the configuration management. So when we talk about configuration management, we're really talking about scripts that you would run or commands that you would issue manually to configure something. Like you want to configure the MTU on a network card, you want to configure the number of threads that a database can handle. All those things, instead of doing them manually, you can use a tool like Ansible and playbooks and configure automatically. And the beauty of all these infrastructure and configuration management tools is that they allow you to specify what your state should look like. And I don't really care how the tool gets there. All I know is that at the end of the day, my infrastructure will look as I've defined it, and my server infrastructure or my application components will be configured like I described. So, John, back to you.
Yep. Okay. Thanks, all. So,
Yep.
you know, when we kind of break this down, we look at the the infrastructure really being the VMs and the configuration management being the software configuration on top, right? So, we're going to kind of talk about that in two separate themes through or two separate chapters, I guess, sections in this presentation. So we'll start up with Terraform and then kind of ease into Ansible a little bit. So. I think we're at a good stopping point here. Are there any questions, any comments, um, anything to add by any of the folks? If not, I'll continue to move on. Okay. So this is really kind of our motto, right? We want to make sure we're using the right tool. Like we said, we don't care if that right tool is Puppet. If your customer is highly invested in Chef, by all means, there's no reason to reinvent the wheel. Just we think in general, using automation, creating infrastructure as code, and being able to manage it in that way is a good idea, and saves lots of pain. So that's kind of our overall motto here, is just use the right tool. It saves a lot of pain later on when you can just quickly rebuild an environment instead of having to go through all the manual steps of installing again. So with that, we'll talk a little bit about Terraform here. So Terraform is a pretty interesting project. Uh, it's run by a company, or owned, I guess, by a company called HashiCorp. HashiCorp owns or has other products that are also relevant in our space, like Packer and Vault and some others. Terraform is their infrastructure as code project, and so uh, Terraform comes in many different flavors. The flavor that you can download is free. You can run this all on your laptop. If you want to build environments, you can quickly harness the power of Terraform and define a template using their HashiCorp markup language, and get up and running very quickly. Like I said, it's free. You can go to terraform.io and download it. And there's tons of examples out there. There's a pretty good community for Terraform, and examples will sort of show the level of interest between the different communities right now. I think AWS is by far the strongest community. You'll find the most examples, probably the most robust provider for AWS, and then VMware as well. IBM's Terraform provider is managed internally by IBM. So, but it's coming along. It's got a lot of new features and functions for deploying things on IBM Cloud. So, again, Terraform is really that engine that that consumes that Terraform template, which defines what your code or what your environment should look like, and then basically tells you what it's going to build, and then you allow it to build that for you. Noel, you want to talk a little bit about Ansible?
Yep, sure. So now that we've got the we've defined which tool to use for defining the infrastructure as code, when we want to talk a little bit about configuration management and how to manage your software packages, the tool that aligns with our portfolio is Red Hat Ansible. It uses Python underneath the covers, and to declare your state, you configure just YAML files where you specify where you want to run, what playbooks you want to run on which host. You define all your variables so that you can have it as flexible as you need to be. And then when we talk a little bit more about Ansible Tower and Ansible Galaxy, or we can see how this whole state can be maintained automatically without having to log on to a server and manually execute playbooks or run commands or validate anything. So John, back to you.
Yeah, and I'll just add, right, Ansible again is one of those that is free, right? You can do a yum install Ansible. You can get Ansible locally on your laptop running any Linux system, and quickly use it to configure other systems by simply creating a host file and a sample Ansible snippet to go and configure things. So it's a really cool tool, but it's also free, which makes it really nice. You don't end up having to deal with licenses and things like that. So free is good. Okay, so let's jump into Terraform a little bit deeper here. So again, Terraform it uses this declarative language. So we are defining in our Terraform template what our server configuration should be, or infrastructure configuration should be. We're not calculating too many things at runtime. We're basically saying, I want this environment to look like this, and you basically tell Terraform to go make it happen. Terraform will talk to the provider through the Terraform provider to the target hypervisor, whether it's AWS or IBM Cloud or VMware, and it will inspect the environment and say, hey, okay, you're telling me I need to have this environment, but I only have these resources available. I can't do it, or I'm not finding the network that you're telling me that this VM has to attach. And so you can kind of work through it a little bit and troubleshoot it and play with it until you get it exactly the way you want it to look. And when it goes through and you run it and it says, okay, everything's good, I can create this. Do you want me to create it? It goes ahead and creates it. So you'll hit go through that provider. It'll automatically build that entire environment for you. Right. So this is declarative. So we've told it how that environment should look. Now that environment, once it's built, if let's say VMware, someone logs in directly into vCenter, they change the amount of memory on that VM without using Terraform to do it. You run Terraform a plan, it goes out and it checks that VM. It says, wait a minute, I only gave you 4 gigs of memory. Now you've got 8. I'm going to put you back the way we've told it that it needs to be configured. So you can sort of eliminate some of that scope creep, right? So things like that do happen where you've got emergency changes, but in that case where there are emergency changes, those changes need to be pushed back into your Terraform so that change will be managed within that Terraform state. So it's a pretty powerful tool, and as you start building these environments, like we build OpenShift clusters and things like that, and when you start building these in AWS and things, you create a lot of different resources. You have to create load balancers and port groups and security roles, and you've got to spin up some block storage and some file storage, and you've got to spin up multiple nodes, and they've got to be across multiple availability zones, and all of these different things, and trying to do that manually is incredibly hard and tedious to go through and create all those resources. And B, when you're done with that environment, there's not a button click that just says delete this environment. So you also need to track what you've created, or you continue to get charged for it. So as powerful as Terraform is at automating that build, it's also really powerful to remove what you've done as well. So you can say, spin me up 1 environment, or spin me up 2 environments, 3 environments, whatever, but you can just as easily say, tear this environment down, which is also a pretty powerful function. So and I think we'll talk about providers here. Yeah, so let's kind of look at a little bit of how this works, right? So we've got our Terraform core, and if you download Terraform for free from the terraform.io, you'll get a single executable, and that file will sit on your laptop, and you basically say create some templates, and you do a Terraform in it. It reads the type of backend providers that you want to talk to, and it'll go and pull down all the providers for that, right? So the plugins will get pulled in from the HashiCorp website, and it'll initialize that environment. Then that plugin will talk to that end state, and we'll sort of broker that deal between the available APIs and the Terraform code that you're running. And so the configuration will look and make sure that it's the resources and the things that you're asking it to build are available, and then it will build and it creates an important file here called the Terraform state, and that's how it basically manages the the changes, right? So if you go and you build an environment and you don't track what you built and somebody makes a change outside of Terraform, you need to have something to compare it to. So you'll have no idea what it's supposed to look like unless you tracked exactly what you built. So it uses that state file, and those state files are really important. We'll talk a little bit more about those later. But it uses those state files to manage that. So that's kind of the way that works. And then if you add, you know, you want to increase the amount of CPUs or increase disks or add another instance, you modify your Terraform code and you do a Terraform apply, and it'll spin up the additional resources and make the appropriate changes on your backend hypervisor, and it will then update your Terraform state with the changes that it made. So that Terraform state is also used when it destroys the environment. When you do a Terraform destroy and you tear that environment down, it reads that state to know what it's supposed to be destroying. Okay, so some of the key concepts here. So we talk about a resource. So a resource is something that's going to be created. So when we talk about resources, we're talking about things like virtual machines, um, hardware like disks, network interfaces, port groups and things like that. These are all resources, things that we're going to create on that backend target hypervisor. And these all can be, you can parameterize these using the different variables and things like that to feed it in to determine some of the characteristics of those resources that you're creating. A provider is a broker between Terraform and the target hypervisor. So you would have a separate provider for AWS versus VMware versus Azure versus whatever the other backend would be, and it also manages your authentication. So you will have to pass credentials to log into these environments, and brokering that handoff is also one of the jobs of the provider. The provisioner. So the provisioner is kind of a nice to have feature in Terraform. It basically allows you to execute some configuration tasks after you've created your environment. So one of the common things that we do, we create a new VM and we want to add SSH keys. So we're going to create some SSH keys, and we want to be able to connect to these VMs once we're done provisioning them. So we'll use a provisioner to execute those scripts and just copy the SSH keys there. Really simple, pretty basic handful of commands. Where provisioners can sort of go wrong is when you start getting into the gray area of when should I be using a provisioner and when should I just be using Ansible, right? Ansible is designed to do that, but if you just have a couple little quick commands, it's kind of easy just to use a provisioner. You can use a provisioner also to just call Ansible. So, we sort of try to draw the line there. If it's something that is quick and easy, that doesn't take a lot of time, or it doesn't have any weight conditions on other components, then a provisioner is the right way to go. Otherwise, you'll start looking at an automation tool or configuration management tool like Ansible. A data source is a source that you are going to have to pull data from. So a data source might be in VMware a data store cluster, right? So you may need to know something about that data store cluster to be able to create a disk on that data store cluster. So a data source is really just a concept that you'll use to pull information so that you can then use that as metadata to create other resources. Modules, if you think of like Java, think of a module as kind of like a library. You can create modules of common tasks, and you can import them into your Terraform to do specific things. One of the things that we did in the past with ICP was we would use Terraform to spin up the basic infrastructure. And then we had a module for installing ICP on top of it. ICP install was pretty much the same as long as we could tell it which components should be installed on which nodes, and away it went. So there's also, if you see the diagram here on the right, there's a module registry provided by Terraform, where there's lots of modules out there that are provided by um, uh, partners, I guess, that allow you to do different types of integration. So you want to do something with Active Directory, there's modules provided by Microsoft out there. If you want to do some database things, so you might find Oracle, other different providers are provided by the different companies to help you integrate with their platforms. Okay, so a basic workflow is plan and apply. So you'll do a Terraform plan, show you what you're going to do, and if you're sure that's what you want to do, you do a Terraform apply, and it will, perform the actions that you've told it to. Once you do an apply, or during the apply, Terraform creates that state file we talked about that manages all of the changes that it's made. In the example of downloading Terraform manually and running it from your laptop, if you're running Terraform locally, you're creating that state file locally. It'll be in the directory where your Terraform's at. It's be called tf state, and so you create this really complicated infrastructure, and then your laptop dies. Now you've essentially lost everything that you've done there. Your infrastructure is still there, but you lose your ability to manage it because you don't have your state file anymore. So Terraform has no idea how to manage it. So that's where we talk a little bit about backends. Backends are things that you can use to manage that state file. So if you look at Terraform Enterprise or Terraform Cloud, or things like our Terraform automation offering within the Cloud Pak for MCM, those provide an additional value add because they provide that back end. So you're no longer sort of tethered to this freeware version of Terraform that you can do things and test, but it's more of an enterprise ready solution. So you can back up those state files that are so critical.
Yeah, one more thing to add there regarding backends. The state file that you generate, that Terraform generates for you, has all sorts of sensitive information. It will have SSH keys. It will have credentials to log on to your infrastructure. It will have everything. So when you're choosing a backend, if you're not using an enterprise tool, something like Terraform Enterprise or CAM or something like that, make sure that you have proper security controls around your backend endpoint. Don't just toss this on an S3 bucket in AWS and forget about it. It will have the keys to the kingdom for that infrastructure. So just something to keep in mind.
Yeah, that's a great point. Just so these state files are not encrypted. It's basically a JSON file. So you can go in there, just like Noel said, you can get the SSH keys, you can get a password if you stored it in there, things like that. So yeah, there is sensitive information in there, depending on what you're doing. So yeah, just make sure that you're aware of that, and incorporate a backend if it fits your needs. The one I used with my testing is Terraform's backend. It's free. You define it in a couple lines of code, and you create an API key. When you run your code, it connects in, it pushes your state file up to their cloud, and you can manage it from there. So it's pretty nice, and it also extends portability. So if I have some code and I want to run that code on Noel's laptop, I can then share that, right? I can pull that down from the cloud and execute it somewhere other than my particular client. Okay, so here's a little bit of the syntax, right? So we have basic argument assignment, right? Image ID equals ABC 1 2 3, and you've got your basic block types, right? So everything is in a your brackets here. When we look at this is a typical resource, right? We define it, resource, and this is a type here that is going to be specific to the provider. In this case, this is an AWS instance, and then we're going to call it example. Right? AWS, you have this concept of AMIs, which are basically your image, and you're going to tell it which image you want to create this virtual machine instance called example on, right? So this would be Ubuntu or CoreOS or CentOS or whatever flavors that they have. There's is a pretty exhaustive list on AWS. And then you just kind of define additional components underneath this resource. You could have a network interface, a disk, or so on. So as you're doing this, you could hard code all of these, or you can look at variable blocks and you can say, I want to create a variable, and there are different types of variables that you can create. In this case, we would have define a variable name would go here, the type of variable, then the default. So you can do strings and maps and lists and Boolean. And then the way you would reference that would be using this markup where you've kind of got the $ with the brackets var.ami. So a variable that you define over here, you would then reference over here. So you have something that's reused a lot or something you want to be able to modify, easily across all of your code. You basically use variables in that way. Okay, so this is an example provider. In this case, this is vSphere. So this is how you would define a provider in your Terraform code. First thing we would need to do is give it this provider name, vSphere. So this would tell our Terraform which provider is acquired. It would go out and pull down the latest vSphere provider, which may be good or may be bad. What we do to kind of mitigate any issues with versioning is we specify a specific version, right? Or greater than a particular version, right? So what happens is these providers have a tendency to change a lot, and maybe in this case we call it virtual instance or something like that. They may change that particular markup in their provider, and the version that I developed my code on may be different than all. So I push it to my Git provider and he pulls it down and he wants to run it. And he hasn't used this before, so he pulls down the latest. And now we have two different, we have the same code that are kind of doing two different things, or one works and one doesn't. So we sort of mitigate that by specifying a version there, and find that that's a pretty good best practice. And then you can also specify your user ID and password here. You can also, for your credentials, each provider is a little bit different. vSphere, what we typically do when we're testing it locally, we'll use environment variables, and it will automatically pull in environment variables with the correct name. With AWS, it's reading config files with your API keys and things like that. So each provider is a little bit different in that way. You could just hard code it in here. And again, different enterprise tools give you different functionality, right? If you don't want to have to store local credentials, or you want this to be shared across the board, those enterprise tools like our Terraform automation tooling allows you to securely store credentials for your connections in a single place and reuse them, and in a much more secure manner. Okay, so data sources we talked about briefly. These are where we want to reference something. We need to create a hard drive, but we need to create it in a data store cluster. How do we do that? We know we sort of build on this construct of data sources, and we have our high-level data source is always our data center in VMware, right? So we get this data from vSphere data center. We've used our provider from the previous slide. We've connected into VMware, and we say, okay, we have a data center called DC. We need to go and get that, right? Or sorry, in our vSphere data center variable, and we're going to go and get information about that. And then we want to go to that data center, and we want to be able to pull in the data store cluster that we care about here. So we want to look for this particular data store cluster in this data center that we're now referencing from up above, data.vsphere data center dc.id. So we need that data center ID to find this particular data store cluster. So the same thing with resource pools, right? We can create a resource. We need to create something in a VMware resource pool. We can get the information about that resource pool, and by passing it in that data center ID that we looked up earlier. So then when we create a resource, we would then reference that resource pool in the same way, vSphere resource pool.pool.id. So it's a really kind of powerful way to look up all that metadata that's required to build those resources in the correct place with the correct parameters, instead of having to go in and specify all the different parameters for a data center, all the different variables that might be available for a data store cluster. It just knows. It goes out and it discovers it. You just say, hey, go get all the information about this data store cluster. I think I'm going to have to create some things in there, and it just does it. So it's pretty powerful concept there. So here's a little bit more of a resource example. So we in this case we're looking at VMware, and this is a vSphere virtual machine. We want to call it CAM Lab. The name of this is going to be Terraform Test. So this is the difference, right? So this is the name of our resource that we will reference in our Terraform code. This name here is the name that you would see if you looked in VMware, right? So you'd log into vSphere and you'd see a VM named Terraform Test. We want to create this in this resource pool ID that we created on the previous slide by looking up that data. We want to create, we're assigning variables here. So we want to be able to, create the storage in this data store, and in this resource pool, we want to give it 2 CPUs. We're going to hard code it to 1 gig of memory. We're going to set the guest ID to Linux 64 guest. We're going to give it a network interface, and we're going to give it a small 20 gig disk. So with this, it's going to go out and build that VM. Okay, so a little bit more about variables, just some examples here. This is your basic string variable, right? We've got maps here where you can say, we've got a particular type that we want to call CAM Lab, and these are the attributes for that CAM Lab type. And then you can reference each one instead of saying, I want to hard code each one. I want to just reference this one variable as camlab dot nodes or camlab dot vCPUs. You can have a variable for a list, basically an array. You can have multiple DNS servers. Some attributes require this, so you'll have to pass in, for example, DNS requires a list. Even if there's only one, you still need to have a list, or your Terraform will fail. And then, this is how you would basically reference them, right? So you've got your standard variable var.vsphere server. You have your map. You would define it this way: var.camlab vCPU, and your path. One of the things we didn't really talk about was this concept of local variables. You can create local variables that are sort of temporary and can be calculated at runtime, and reference those in that way. Let's see here. So a sample kind of layout here is you would have a directory where you would create your Terraform code, and you would go and once you've got this to a point where you think you want to test it, you would do a Terraform plan. On the right-hand side, this is kind of the output of that, right? It's going to show you with these red pluses all of the things it's going to add, and that it's calculated that it needs to run. This is great if you have syntax errors. At this point, it's going to tell you it can't connect to your provider. It's going to tell you this is all it's going to actually kind of do a dry run and talk to that backend hypervisor and make sure that all of the components that need to be there that you've referenced are there. And again, in the way that this particular example uses the user IDs that we're passing as environment variables. So vSphere user and vSphere password are set as exported environment variables, and when that provider runs, it goes out and connects using those credentials. So the plan basically says, this is what I'm going to do. And then you can run the apply, right? So the apply basically does the same thing as plan. It's going to show you what it's going to do. The only difference is it's just going to say, are you sure you want to, right? Yes, I definitely want to do this, right? So this is your last chance. Once you click yes, it starts doing stuff. And you'll see the screen scroll, scroll for a little bit with all the resources it's creating or waiting. So once you click go, you can you can open up another window with your backend hypervisor, and you can watch all of these things be created. So this is where kind of the magic happens. And at the same time, while it's doing that, it's creating this TF state file. Right? So as it's creating all of these things, you'll see this Terraform TF state file here in the same directory. This is an example of that TF state file. Like we said, this is just JSON format. It's going to have all of the information about all of the things that it's creating for you in the backend hypervisor. This is an example for VMware. So if you want to see what's in there, you could just open it up in your favorite editor. You can do Terraform show if you want, and you can use this to list particular attributes that you want to know about that environment that you've created. You want to get a list of host names or a list of IPs or the amount of disk or whatever. You could do Terraform show and then kind of see the output based on the dot notation for your Java, right? Resources dot mode, right? And it'll show you data, right? The different components are easily accessible using Terraform show. And then the opposite of the apply is the destroy. So when you run destroy, it's going to show you with these red minuses here all the things that it's going to destroy. So this is the part where you really want to make sure that you know what you're doing, because you want to make sure that you're not destroying some production instance or whatever. And it's easy to get into the habit of just clicking yes, but this has come back to bite me more than once to make sure that you know exactly what you're deleting before you do it, especially if you're running this stuff locally. You've got different directories, different state files, and it's easy to blow away the environment that maybe you've been working on. So, and again, it just asks you yes, reads that state file, and away it goes.
Yeah, John, let me add one thing here. Can you go back one slide to Terraform apply? Yeah. So one thing to keep in mind when you do a Terraform apply, it depends on your provider. For example, if you're using VMware and in your Terraform code you say, oh, this server now needs, I want to change it from 4 CPUs to 8 CPUs because I have more demand now. You need to be aware of how that provider works underneath the covers. And the way vSphere works particularly is that it won't just add 4 CPUs to the virtual machine. It will actually destroy the virtual machine and recreate it with 8 CPUs. So that's something that you need to keep in mind, and that's something where configuration management comes into place as well. Once that VM gets recreated, how do I configure it? So keep in mind when you're doing applies, be very, very mindful of what the plan looks like. You might end up destroying machines that you were not aware that, or you weren't aware that just by doing an apply, you would destroy and create a new one.
Yeah.
That's
all providers are not created equal. Some will have different functionality depending on the platform and the level of maturity. So yeah, be aware of that behavior before you get executed, or check the output of your apply before you actually do it. So we'll show a delete and then a re-add. Okay, so I think I'm talking a little bit too much here. Let's see if we can't. Okay, modules. We talked about these. These are kind of important because they'll provide kind of a library of things that you can import in. You can import these in via GitHub, and you can go in and pull that directly from a Git repo with that particular tagging. Reusable code. It's really a pretty powerful concept. It's a bit advanced, but it's incredibly powerful. Managing your state, your backend state is important. I think we've covered that pretty well. This is an example of the backend that I use for using the out of the box Terraform backend. So pretty simple to set up and pretty nice to have. This is an example of a provisioner where you would execute a simple script after they were provisioned. So the VM is there. We're going to connect to that VM using the user ID and password that we gave it in this host. We're going to copy some files to that system from the local system where you're executing your Terraform, and then basically execute those scripts in this order that they're defined in this list. Okay, all right. Sorry,
All right.
I've put you up against the end here, so I apologize. And I think we got 10 minutes here.
Yeah, we should be good. My answer was pretty quick. All right. So next slide. All right. So there are a couple of core concepts that we need to be aware of with Ansible. There are inventory, variables, playbooks, and tasks. So let's just start with inventory. An inventory is just a way of grouping servers together. The default Ansible inventory is etc Ansible hosts. You should try to avoid using that default inventory because that one requires root access. So that means that you need to execute your playbook as the root user, and that's not a good not a good best practice. So in here you'll have, for example, you can have servers that don't belong to any group, like mailexample.com in this inventory. You could have servers that are defined as web servers, or you could have servers that are defined as database servers. You can just define them. You can create whatever grouping you want by grouping them, creating like a section with brackets, and then either putting IP addresses or host names or regular expressions in there. So you can have web 1 through 10, which is that single web bracket 01, 10 line. Next slide. All right, so when we're talking about the inventory file, we have a couple of groups that are special. We already talked a little bit about web, database, development, productions. You can mix and match. So you can have web servers defined as web 1 and web 2. But your development web server is web 01 and your production web server is web 02. You can mix this and match host names here to define your groups as your environment needs. Apart from all these groups that you define, there are 2 special groups that are included with every inventory file that you run. One is the all group. So that means every host in this inventory file, regardless of where it's located in the group. And then unbound, which means any server that's not part of the group or of any group. So in this example, unbound would be mailexample.com, and the rest would be under all, and everything else would be all, including mailexample.com. Next slide.
Sorry.
Yeah, all right. So we also can define variables in this inventory file. And the way we do that is we extend the group. If you see on the first group, we have something called web, which includes web 01 and web 02. And since these are web servers, they're probably running Apache, for example. When we configure it, we want to pass along where the web document group is going to be. So you can create a special group underneath this inventory file called web::bars. And what this will do is for every server inside the web group, it will have a special variable web root, or it will have a special variable associated with each server in the web group called web root. Same thing for the database var files. Every server on the DB group will have a variable called DB name. And that's how, this is basically how you define your variables with in your inventory. There are other ways to do that, but this is the easiest and generally best practice. Next slide. All right, so let's talk a little bit about playbooks. Running a little bit out of time, so let me just see how I can speed this through. So playbook is a collection of tasks, and these tasks define how what my state is going to look like. For example, in this particular playbook that we're looking at, I am going to execute on all the hosts that are in the web group. I'm going to log on as root user, and I'm going to become root. And I am going to install the HTTPD package if it's not installed. And I'm also going to make sure that Apache is running after it's installed, if it needs to be installed. Next slide. All right, so executing playbooks, pretty straightforward. Like we said, we don't want to use the default playbook because it requires root access. So you can pass the -i variable to Ansible playbook and specify your inventory. And then you just specify the path to your playbook. We're running here the same playbook that we showed on the slide before. So it's going to go out to all the servers in the web group. It's going to gather facts. It's going to install the latest version of Apache. It's going to make sure that Apache is running. And then it's going to show a recap of everything that the playbook did. In here, you will see if everything worked correctly. You'll see OK and the number of tasks that ran on each server, how many changes it made, and then if anything was skipped or whatever. So let's say, for example,
you'll notice this looks very familiar to our Cloud Pak installers, right? We use the same Ansible playbooks in our own Cloud Paks to install our own code. So it's it should be something that some of you have seen, and maybe you didn't even realize that you've seen it.
Yep. So what happens if we have our sneaky SRE and he logs on to a server and decides that Apache shouldn't be running here? Can you show the next slide? So what happens if I execute the same playbook again, right? It won't install Apache because it already detected that it's installed. But it did detect that on web server 1, Apache wasn't running. So it brought it up by itself. And that's really powerful. I mean, this is a simple example of just Apache running. But think of your application that someone might accidentally delete your application from a Kubernetes cluster. You could have a playbook that is constantly checking if the application is there, is it there? And if it's not there, it deploys it. Or you could have any other configuration management that does that. But the point is, and if we have time, we'll talk a little bit about Ansible Power. Once you have that, you have an automated way of making sure that Apache is always running. And if someone makes a change to that state without going through the proper authorizations, then my playbook will make sure that I have the desired state. Next slide. And the last thing I wanted to demo here is we've talked about Ansible and Terraform better together. So we do have a couple of, we have an Ansible or a Terraform module. It's listed down there in the bottom that it just allows you to run playbooks. And it's documented in that link. It does the same thing that we've been doing here. It just goes to all the web servers and checks that it's running. If it's not running, it will start it. If it's not installed, it will install it and then start it. But the point is we have tools out there that can help you integrate everything. It doesn't have to be a Terraform Ansible run playbooks. It could be Terraform Puppet or Terraform Chef. The point is you can take a look at that code and figure out how to make it work with any other configuration management tool. Next slide.
Okay, so I think on this we can basically skip this. We're right at the top of the hour here. So there are some examples here. So they go from basic to pretty advanced. If you're looking for syntax on some of the Terraform modules, some of the things that we've done, you can go there. Some of the enterprise environments around Terraform that we have in our IBM portfolio. First one is Schematics, which is an IBM cloud offering. Basically allows you to execute your Terraform code from IBM Cloud, manages the backend state. It's a pretty interesting Terraform as a service platform. So if you're doing things provisioning cloud-based workloads, that's certainly something worth looking at. We have our Cloud Automation Manager, which is now in the latest release of our Cloud Pak Terraform Automation. And this has been around for a while. It provides Terraform automation with additional self-service and management with some process orchestration as well in there. This is bundled with the Cloud Pack for multi-cloud management. Also a pretty full-featured tool. You want to handle Tower?
Yep.
No?
And last but not least, we have Ansible Tower. It's also now included with the latest version of the MCM Cloud Pack 1.3. And it deploys as a container inside your OpenShift environment. And basically, it just allows you to have a centralized place to run all your playbooks instead of just running it from your laptop. It provides an environment where you can have audits. It's audit ready. You have all your logs. You have all your playbooks, your host. Everything is in one centralized place instead of multiple laptops around. I think that's all I have, John.
Okay. And just you know, on the Ansible Tower note, there it is included in the Cloud Pack for multi-cloud management as well.
Yep.
So this, just to kind of wrap things up, you know, again, make sure you're using the right tool for the right job. The way we see it, and the tools that we like to use are Terraform for infrastructure, and Ansible for our configuration management. But you know, by all means, if you've got environments that have specific tooling, or you've got a customer that's already invested time and money in another tool, you know, by all means, leverage those to meet the same ends. And you know, we think it's smart to kind of start with, you know, playing around with some of these free tools to kind of see the power, but make sure you're leveraging those enterprise solutions for large scale deployments. So I know we've run late, but if there are any questions, I think we're you know, more than willing to hang out and answer them, or if you'd like, you know, we can kind of take a look at the Slack channel as well and answer them offline.
So, Jackie here.
Hey, Jackie.
Just a quick question. Do you have some use case, like, you know, how did you use Terraform or Ansible to actually orchestrate cloud environment? For example, like a customer that got AWS and the Google, how they use these kind of tools to achieve certain kind of efficiency.
Mm-hmm.
Yeah, so the best example for that one would be the automation that we developed for OpenShift 3.11. OpenShift, the OpenShift installer is basically just Ansible. It's an Ansible playbook, just like our Cloud Pack installer is an Ansible playbook. So what we did is we had Terraform code that created all the infrastructure, all the load balancer servers that configured, Red Hat registry, everything. And then we had this playbook, which we showed that just called the OpenShift installer playbook, and it would just deploy. If you reach out to me directly, I can send you the repository that we have out there for OpenShift 3.11 on different cloud providers, and I can show you exactly how that integrates so both of them can work seamlessly.
Yeah, with OpenShift 4, it's a little bit more difficult to automate, especially if you're not on one of the preferred kind of OpenShift platforms. But we still do find a fair amount of value there with automating the infrastructure build and things like that as well. So the DNS and some of the DHCP requirements and things like that throw a wrench into that, but we're hoping that will get a little bit better.
All right, thanks.
Okay. Amit, I don't know. Do you have any closing words?
No, I'll just stop let me stop the recording first.